in the test calculator is that it's limited to simple form structures. So I just wanted to take a little bit of time here to express my thoughts on that, how it applies, and essentially look at a few different forms here in SketchUp, give some comments on if I think it's a simple or potentially a complex form structure, how that applies to the building code and how we might be interpreting it, and how we might be inputting values into the calculator. So this is, you're going to have to use your imagination, but let's imagine that this here is a house. A two-story house. The lower floor is 40 feet by 20 feet, and the upper floor at the moment is also 40 feet by 20 feet. I would consider this a simple form structure. It's very easy to input into the calculator in terms of its building dimensions. Again, we'd have 40 feet along one axis and 20 feet along another axis. This stacks above and below. I would consider the lower story as being a story for bracing that is supporting a roof plus one floor, and the upper story being the roof only. Obviously, not all buildings are designed this way or constructed this way, so how do we deal with articulation? How do we apply it to the building code? And potentially, how do we make changes in the calculator that can accommodate these different building forms? The first change that we can make is we can produce some simple articulation by pulling something out here. And this is pretty simple and represents something similar to what I used in my previous example. Again, there's some articulation that's produced, changes to the building design. But importantly, the stories above and below are stacked exactly. And so what is important in terms of bracing is that the building dimensions would remain the same. But obviously, again, not all forms of buildings look like this. So I'm going to put this one back and we'll look at some differences. So back to our original structure. So we know that brace wall bands can be a maximum of 1.4 meters in width, and this permission provides opportunity for designers to make some small changes to building articulation without too much of an impact on the design. So if we were to give an example of that, if I was to push this top story in by 2 feet, we could get some articulation to the building, changes to the building design, but the brace wall band here at the front of the building is permitted to be 4 feet wide, so it could encapsulate this articulation. In this case, the building dimensions on the lower floor of 40 feet by 20 feet are still going to match the building dimensions on the upper floor as 40 feet by 20 feet. So again, this is very easy for the calculator to handle. But what about if on the back of the building here, for example, we do something a little bit different, and instead of pushing in, we produce a cantilever on the upper floor of 2 feet. How are we to address this change in the code and hence in the calculator? On the lower story, we have building dimensions of 40 feet by 20 feet, but now on the upper story, we have a dimension of 22 feet, which is obviously larger than the building dimension downstairs. Now again, this is an articulation that is permitted by the rules of the building code. You could have a brace wall band at the rear of the building here that is essentially 2.5 feet wide, and it's going to capture both of these building faces. At the moment, the only way to address this in the calculator, in my opinion, is to pull down this greater dimension of the upper floor of 22 feet and apply that as the horizontal dimension in the calculator. So instead of having 20 feet by 40 feet in the calculator, you would have 22 feet, by 40 feet. Now that might be a suitable way to do this. I don't exactly know, but it would be one way to apply the same building dimensions to the lower and upper floor, essentially in the most restrictive case of the code. What that means basically is that for the calculations that have been applied through the building code formulas, the building dimension, the greater building dimension, is going to be applied to the lower floor and the upper floor. And so that might be suitable. I'm going to push this one back in. So furthermore, on the uppermost floor, if we to make another change here to the length of the building and push this in, say by 3 feet, again we're producing a different form to the building, some more articulation. The brace wall band layout, doesn't need to change. Again, we have a jog here of less than 4 feet, so the lower brace wall band is going to encapsulate the upper brace wall band as well. But our building dimensions have shifted again. So on the lower floor we have 40 feet by 20 feet. On the upper floor we now have, I think I did 3 feet there, I'll check. Yeah, so we have 37 feet by 20 feet. So again, how do we address this in the building code? At the moment in the calculator I only have one entry for the building dimensions. So we could handle this in the calculator if we believe that it is okay to assume that even though that there is this step back here, the maximum building dimension is 40 feet on the lower floor, and so the maximum building dimension in that orientation would be 40 feet for the calculator. There would be, in my opinion, some penalty that has been applied to the upper story here because the building dimension is obviously less on the upper story, and it's not being reflected in the calculator. It's certainly possible to build in the logic into the calculator where we apply a building dimension to each story. And as I move through some of these examples, just maybe keep that in mind. So when I'm considering a simple form structure, I'm considering a structure where the stacking of the brace wall bands is capturing all of the exterior walls, and the building dimension on the horizontal and vertical axes can be reasonably applied to all the stories for bracing. Okay, that means that if you're a designer or a builder or even a building official, I guess, like if you're designing something like this and you are happy to pay the penalty, I guess, for having to design this story to a building dimension of 40 feet, even though you only have a 37-foot building, the calculator will work for you in its current iteration, in the test iteration. With the example, and this may be for designers and building officials, with this example, if you're producing a cantilever, again, if we consider this a simple form structure and we're applying the same building plan dimensions to the upper and lower floor so that we can use the test version of the calculator, the dimensions would be 40 feet in this case, so that would be the most restrictive on the lower story, and there would be 22. I don't know what I did there, but yeah, over the 20 feet. So the projection of that cantilever is going to produce the the most restrictive building form in terms of the bracing calculations. So that would be another example of how we could apply this form to the calculator and do it as what I would consider a simple form structure. So I'm going to keep moving on with some different examples here, because obviously, again, like not all buildings are like this. So let's push this back in. Focus on the front of the building. Now this goes beyond, what I'm about to explain here goes beyond the test version of the calculator, but it's something that I'd like to hear people's thoughts on for input, because it's going to help me develop the logic to best suit people's understanding of how the building code applies. So now we'd be moving from what I consider simple form structures into complex form structures. And for a complex form structure, my thoughts on the logic are that the building plan dimensions, in terms of the calculations for bracing requirements, can be changed depending on what story you were making the bracing calculations for. And I'll define that here a little bit more. So again, looking at our building form, the first example that I use, if I push this all the way in, okay. Let's say hypothetically that this portion of the lower floor here is actually a garage. It's an attached garage, but it is only a garage. Then to the left of it, we would have like the main portion of a house. So a two-story house with an attached garage. It's a pretty simple form. It's actually illustrated in the BC Housing Illustrated Guide as well. And so what do we do in this situation? And let's make the assumption now that there are no additional system considerations applying to this, so nothing related to the garage or any setback walls or anything like that. Let's just stop with those ideas for the moment. So in terms of the building dimension, on the lower floor here, we obviously still have our 40 feet along the horizontal axis, and we have 20 feet along the vertical axis. But on the upper floor, we have a dimension of roughly 23 feet in one direction and 20 feet in the opposite direction. Now hypothetically, if the brace wall band system below had a brace wall band at this point that's stacked on the lower floor, so essentially the wall dividing the garage and the house, and then stacked to the story above. On the upper floor, we would only have two bands. Well, let's say there's one on the exterior here and one just this and no interiors. We'd only have two bands, but on the lower floor we would have three bands. And so my thoughts are that I think it would be a pretty severe penalty if a designer and a builder had to apply the bracing requirements based on this building dimension for the lower story and the upper story. But how do we account for that? I don't really know. As I said, it is possible to build this into the logic, so we could have, of the calculator, we could have a building dimension for the second floor, so the wall supporting the floor only, and that could be used to reflect the bracing requirements for this story, and then for the lower floor we'd have the greater dimensions that could be used for calculating the bracing requirements for the lower floor. The other obvious question that comes up about this is that here we have the garage with an exterior wall, and this dimension here, the width of the garage, represents a wall that is set back in one orthogonal direction. There's guidance in the code that says, well, there's a code clause that says that upper stories can be set back. One wall in each orthogonal direction can be set back from a wall below. And so the question comes, like, what does that actually mean? And then are there any sort of additional thoughts around that? And again, I might be missing something, but in this case, if you have a band on the lower floor that needs to project into the upper story, does this constitute an orthogonal setback? All right, the wall is set back from beyond a distance greater than 1.2 meters for the story below, but the system, the bracing system, is continuous. So previously, I've heard of jurisdictions regulating this in different ways, but that's a question that I have for users and potentially for code writers is, does this situation represent an orthogonal setback if this band is continuous along the exterior wall above, and the interior wall below. So at the moment, the way that the calculator is set up, it's going to be difficult to design bracing calculations for a building form like this unless we are applying the single building dimension in this direction and this direction to the entire build. So that if you wanted to do that, that is possible in the calculator. When you're entering the details for the bands, you would have a building dimension in these two directions. It's going to be applied from the main page, and then when you get to the second page, you're going to be producing two brace wall bands and then a spacing between them. So it is possible. I haven't done many examples like that. I guess from my logical perspective, it seems more fair to a user to be able to apply a building dimension to this upper story in terms of the calculations for that upper story. But I'm not sure if that's the intention behind the code writers, and I'm not a structural engineer. I have no experience designing a building like this. Like, I don't actually understand how the bracing systems might be affected from one to another. So let's again just use another example here. We'll keep moving along. And so now we're going to address something that would be considered an orthogonal setback using the additional system considerations. So let's assume that this section down here is still a garage, and above it we've built a structure that carries over the garage, and it is set back more than 4 feet in this direction. Oops. And more than 4 feet in this direction. Okay, so if we are using the additional system considerations, it is possible to set back our walls greater than 1.2 meters or 4 feet in each orthogonal direction, which I've done here. Now, if this is a garage and it is completely open below, and say we have a wall running through the building here that we can place a band in, that's going to stack and capture this. But if this is completely open below, these two walls here are not going to have a brace wall band beneath them. So there's not going to be any stacking of these brace wall bands below these two orthogonal directions. Now that is permitted in some circumstances based on the construction in this space, the sheathing there, and then the spacing of the bands on the rest of the system. I'm not going to get into that now. I'm primarily concerned with how we would address this building form in terms of the building dimensions. So I previously used the example with the garage below and this wall set back in line with the band below. So I'm not sure if that should be an orthogonal setback or not. But in this case, it's definitely something that would be an orthogonal setback. So again, the same questions come up. On the lower story, we have a 40 by 20 building dimension. On the upper story here, if we were to measure the upper story, we would have just nearly 35 feet in that direction, but we would still have a building dimension of 20 feet in this direction. So the questions come up, would those two dimensions be an acceptable way to apply the bracing length calculations to the upper story only? Can we separate the building dimensions for the lower floor and the upper floor to provide more nuanced calculations? I don't know the answer to this. It is absolutely going to change the logic in the calculator. And so to keep it simple for users at the beginning, as I said, this test of the calculator only addresses simple form structures. So the main principle of that is that a simple form structure is a building or a form where you are applying the building plan dimensions as the same for all stories of bracing. So just keep that in mind as you're moving through the test. It currently only addresses like one number for the horizontal building dimension and one number for the vertical plan dimension. So when you're looking at building forms like this, there's essentially going to be a severe and maybe not an appropriate penalty to the upper story if you are applying the greatest building dimensions.